This time I'm going to take another topics in algebra, and this time we will see what we call algebraic expression. Example, let's take A. A is variable. So what is the value? Let's take any integer or number. This time I take 2 as the value. So A equal to 2. This is the value for A. Only for this example. If it is another variable, it will represent another value. Variable value. Example, B equal to 10, X equal to 1, Y equal to 0, whatever. Here I take some alphabet: A, B, X, Y, and these all are alphabet, but in this algebra we call it variable. And the number assigned to the variable is their value respectively. 2, 10, 1, and 0 are all called value. Variable actually represent unknown. Variable unknown. This means we still do not know the exact value for the variable. So unknown can be represented by variable. Variable is unknown. Variables unknown variables, and we see this is a rectangle using unknown to represent their size. Why we use unknown? Because until now we still don't know what is x. After we calculate and find the exact value, then the variable will be having one exact value, and this time the variable is not unknown. This is a rectangular with unknown value for their sides. This is another example how we use variable to represent unknown. This time the unknown is height of the tree. In this example, h is a variable. This is one of a alphabet. Variable is like a container. For example, if x equal to 1, we draw a container and we put one thing in the container. And if x equal to 3, so we can write a container with 3 things in the container, something like that. We can think variable as a container like this. When we later we can find out that x or other variable can be replaced by bracket. We can use bracket, we can use bracket like this to replace the symbol. For example, x equal to 1, y equal to x. So y is 1. Y is 1. So x now is a bracket. So if you think as a container, it can be alright as your method of thinking. You could, if we are given a problem with y equal to 3x and set x equal to 2, so y is 3 and the bracket will be filled with the value of x 2. 3 multiplied by 2 is 6. This is how we think about variable. We put the value given in the variable represented by bracket. if x equals to 0, so y is 3, 0. So 0 means 0. In this example, we put 3 and a bracket. What we do is we actually multiply 3 multiply with the value in the bracket. This multiply as shown before. 3 with 2 equal to 6. Understanding this rule, now we try this one. A is equal as 5 in the bracket. What is the value in the bracket? 2. 2 is the value, and we multiply, we got 10 as the value of 5a. Now, what is the value of y if y is 6a? 6a. Y 6a. So what is the value for y? Same as before, 6 and a bracket. What is in the bracket? 2. What we will do next? We multiply 6 with 2 and we got 12. We will get 12. Become term. For example, y and number 2 or integer 2 will produce 2y. 2y is term. Y is variable. Y is variable. Look at this example. if you not found any number here, this means the number is 1. If you cannot see any number, any integer here, only sign of negative, it means -1. So from now on, in your mind, if you cannot find anything here, that means the integer is 1, and here you cannot find any number, so the number is actually -1. 2x, -3x, q, and -p. 2x, -3x, q, and -p are all called terms. They are all algebraic terms with 1, the variable is x, q, and p. X, q, and p respectively. Like terms, unlike terms. Like term is the variables with same symbol. Variable with same symbol. And unlike variable with different symbol. Like term and unlike term, we can recognize like and unlike when we see the variable same symbol or different symbol. Like variable, x, 2x, -x, it's like symbol. Like term, there are like terms. There are like terms. 3 like terms. Unlike term like this: x, y, z, 2y, xy. This is all unlike term. Unlike term, they have different symbol. What we want to know and want to recognize like or unlike. In addition and subtraction, only become two like term. X plus y plus 2x plus y only x can add to x, y can be added to another y. That's the importance of knowing like term. How to solve this addition? M must be added with M like term. So M plus 2M. And then see where will we find another n, variable n, plus n plus 5n, and a only one single with a pair, so write again. What happened? M plus 2m, 3m, n plus 5 becomes 6n, and so write again 3a. We cannot add n with n because this is a unlike term. They are unlike term. P plus P plus R plus 2R plus S plus 2S, and simplify this expression. We can simplify this expression by group this same variable like term 5 and 1 6b. This is one term, and R and 2R will be another one term with R, and the last one S and S put together into one term because they are like term 3. s. And this is what we try to find, and this is the simplest form. Okay, now we can say the expression has simplified. Another example, plus 1 2d plus d plus 3 plus d plus 2e plus 1. This time we have a number without any variable. This is we call constant. 3 and 1 are constant. So 2d with d, e with another e to e, and constant with constant. 2 and 1 d plus 3e plus 4. The constant is constant. Constant means we cannot change their value. If we say 4, it means 4. This is addition for like term. We use the same rule. To subtraction. Subtraction using the same method, same way, same rule. For example, x plus y minus x minus y. We still use same variable, like term. The x minus x. Only like terms can be subtracted. Plus y minus y. Like terms can be subtracted. 2x and this one is 0, so no need to write it. We cannot subtract like this two unlike terms. Only like term can be conducted in additional and subtraction. Okay. How about multiplication and division? Multiplication and division in algebraic terms like this. This is two like term. Two like term we can multiply directly, become 2x power of 2. We also can multiply unlike term like this. It will be x 2x after that multiply with 3y. The coefficient can be multiplied directly and becomes 6, and xy like this. This multiplication same as in division. We can divide two unlike and like terms. If we found unlike, we cannot divide further. It will stay like that. No further solution if we divide unlike terms. This is the contents that I feel to be introduced in this series of thematic mathematics. Maybe next time I will bring another topic and another example in algebraic expression. We will continue next time how to write algebraic equation and linear and quadratic equation. Thank you very much.